around us pure. Learning about solutions, suspensions, and colloids. Solutions, suspensions, and colloids. Before we discuss the solutions, suspensions, and colloids in detail, we should know the meaning of two terms: solute and solvent. The substance which is dissolved in a liquid to make a solution is called solute, and the liquid in which the solute is dissolved is called as solvent. For example, salt solution is made by dissolving salt in water. So in salt solution, salt is the solute and water is the solvent. Usually, the substance present in lesser amount in a solution is considered the solute, and the substance present in greater amount in a solution is considered the solvent. The solute particles are also called dispersed particles, and solvents are also known as dispersion medium. Solutions. A solution is a homogeneous mixture of two or more substances. Some common examples of solutions are salt solution, sugar solution. Salt solution is a homogeneous mixture of two substances, salt and water, whereas sugar solution is a homogeneous mixture of two substances, sugar and water. The true solutions are also known as molecular solutions because the size of dissolved particles in such solutions is the same as that of a molecule. Some more examples of the solutions are seawater, copper sulfate solution. The substances like salt, sugar, etc., which dissolve in water completely, are said to be soluble in water. Only soluble substances form true solutions. To study the properties of a solution, if we shake some sugar with water in a beaker, the sugar seems to disappear in water, and we get a transparent sugar solution. The dissolved sugar particles cannot be seen even with a microscope, and the sugar does not settle down even on keeping the solution for quite some time. If we filter the sugar solution, the whole solution passes through the filter paper and no residue is left behind. The sweet taste of the sugar solution, however, shows that sugar is present in it. From these observations, we conclude that sugar solution is a homogeneous mixture having the same composition throughout. Sugar solution is a true solution. In a true solution, the particles of the solute break up to such an extent that they disappear into the spaces between the solvent molecules. So, in a sugar solution, the sugar particles break up to such an extent that they disappear into the spaces between the water molecules. A sugar solution does not scatter a beam of light passing through it and render its path visible because the sugar particles present in it are so small that they cannot reflect. We will now state some of the properties of a true solution. Properties of a solution. Types of solutions. We usually think that solutions are formed when solid substances are dissolved in liquids. Though most of the common solutions are made by dissolving solids in liquids, but this is not always so. Let us see how various types of solution dissolved. Please remember that as long as the mixture is homogeneous, the term solution applies to it. The various types of solutions are: solution of solid in a solid. Metal alloys are the solutions of solids in solids. For example, brass is a solution of zinc in copper. Brass is prepared by mixing molten zinc with molten copper and cooling their mixture. Solution of solid in a liquid. This is the most common type of solutions. Sugar solution and salt solution are the solutions of solids in liquids. Solution of iodine in alcohol called tincture of iodine is also a solid in a liquid type of solution. This is because it contains a solid iodine dissolved in a liquid alcohol. Solution of liquid in a liquid. Vinegar is a solution of acetic acid, that is ethanoic acid, in water. Solution of gas in a liquid. Soda water is a solution of carbon dioxide gas in water. Solution of gas in a gas. Air is a solution of gases like oxygen, argon, carbon dioxide and water vapor, etc. in nitrogen gas. Nitrogen is the solvent in air and all other gases are solutes. Suspensions. Substances which are soluble in water form suspensions. A suspension is a heterogeneous mixture in which the small particles of a solid are spread throughout a liquid without dissolving in it. Some common examples of suspensions are chalk water mixture, muddy water. Chalk water mixture is a suspension of fine chalk particles in water. Muddy water is a suspension of soil particles in water. Please note that solid particles and water remain separate in a suspension. The particles do not dissolve in water. To study the properties of a suspension, if we shake some chalk powder with water in a beaker, a milky suspension is formed. We can see the fine particles of chalk suspended throughout the water without dissolving in it. If this suspension of chalk and water is kept undisturbed for some time, the chalk particles settle down at the bottom of the beaker. This means that chalk and water suspension is unstable. If we filter the suspension of chalk and water, the chalk particles are left behind as a residue on the filter paper, and clear water is obtained as a filtrate. This means that chalk and water suspension can be separated into chalk and water by filtration. And if a beam of light is passed through a chalk and water suspension, it scatters the beam of light and renders its path visible inside it. From this discussion, we get the following properties of a suspension. Properties of a suspension. The important characteristic properties of a suspension are given below. A suspension is a heterogeneous mixture. The size of solute particles in a suspension is quite large. It is larger than 100 nanometer in diameter. The particles of a suspension can be seen easily. The particles of a suspension do not pass through a filter paper. So, a suspension can be separated by filtration. The suspensions are unstable. The particles of a suspension settle down after some time. A suspension scatters a beam of light passing through it because its particles are quite large. Colloids. A colloid is a kind of solution in which the size of solute particles is intermediate between those in true solutions and those in suspensions. The size of solute particles in a colloid is bigger than that of a true solution but smaller than those of a suspension. Though colloids appear to be homogeneous to us, but actually they are found to be heterogeneous when observed through a high-power microscope. So, a colloid is not a true solution. Some of the examples of colloids or colloidal solutions are soap solution, starch solution, milk, ink, blood. To study the properties of a colloid, if we shake some soap powder with water in a beaker, we get a colloidal soap solution which is not perfectly transparent. It is somewhat translucent. The soap particles cannot be seen by us. If the soap solution is kept for some time, the soap particles do not settle down, showing that it is quite stable. If we filter the soap solution, the whole solution passes through the filter paper and no residue is left behind, showing that it cannot be separated by filtration. All these observations indicate that soap and water mixture is a true solution. The scattering of light by a soap solution and the examination of soap solution under a high-power microscope, however, show that soap solution is not a true solution. The scattering of light by colloidal particles is known as Tyndall effect. So, a true solution can be distinguished from a colloidal solution by the fact that a true solution does not scatter a beam of light passing through it, but a colloidal solution scatters a beam of light passing through it and renders its path visible. The particles of some of the colloidal solutions can be seen through a high-power microscope. For example, if a drop of milk is examined under microscope, we can see the small particles of fat floating in the liquid. This observation shows that colloids are heterogeneous in nature, though they appear to be homogeneous. Properties of colloids. The important characteristic properties of colloids or colloidal solutions are as follows. A colloid or colloidal solution appears to be homogeneous, but actually it is heterogeneous. The size of particles in a colloid or colloidal solution is bigger than those in a true solution, but smaller than those in a suspension. The particles of most of the colloids or colloidal solutions cannot be seen even with a microscope. The particles of a colloid or colloidal solutions can pass through a filter paper, so a colloid cannot be separated by filtration. The colloids or colloidal solutions are quite stable. The particles of a colloid do not separate out on keeping. A colloid or colloidal solution scatters a beam of light passing through it because its particles are fairly large. Though colloids cannot be separated by the process of filtration, but a special technique known as centrifugation can be used to separate the colloidal particles from a colloidal solution. Separation by filtration. The process of removing insoluble solids from a liquid by using a filter paper is known as filtration. Filtration is used for separating insoluble substances from a liquid. The mixture of insoluble solid and the liquid is poured into a filter paper cone fixed in a funnel by using a glass rod as a guide. The liquid passes through the filter paper and collects the beaker kept below the funnel. The solid particles, being bigger in size, do not pass through the filter paper and remain behind it on the filter paper. The solid substances left behind on the filter paper is called residue. The clear liquid obtained is called filtrate. In this way, a mixture of insoluble solid in a liquid is separated into the solid and clear liquid. To prepare a saturated solution, we will describe the preparation of a saturated solution of a substance, say sodium chloride, at a temperature of 30 degrees Celsius. We take some water in a beaker and heat it slowly with the help of a burner. Now, we start adding sodium chloride, that is salt, to the hot water with a spoon and stir it with a glass rod continuously so that sodium chloride goes on dissolving in water. We take the temperature of water up to 30 degrees Celsius and then, keeping this temperature constant, go on adding sodium chloride till no more sodium chloride dissolves in it, and some sodium chloride is also left undissolved at the bottom of the beaker. The contents of the beaker are now filtered through a filter paper arranged in a funnel. The clear solution obtained in the form of filtrate is the saturated solution of sodium chloride at 30 degrees Celsius. If a saturated solution of sodium chloride at 30 degrees Celsius is allowed to cool, then the crystals of sodium chloride will reappear in the solution. Actually, on cooling the solution, the solubility of sodium chloride in water decreases, due to which some of the dissolved sodium chloride separates out from the solution and forms crystals. At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. The amount of the solute present in the saturated solution at this temperature is called its solubility. If the amount of solute contained in a solution is less than the saturation level, it is called an unsaturated solution. We can infer from this activity that different substances in a given solvent have different solubilities at the same temperatures. The concentration of a solution is the amount of solute present in a given amount, that is mass or volume of solution, or the amount of solute dissolved in a given mass or volume of solvent. Concentration of solution is equal to amount of solute upon amount of solution or amount of solute upon amount of solvent. There are various ways of expressing the concentration of a solution, but here we will learn only two methods. Mass by mass percentage of a solution is equal to mass of solute upon mass of solution multiplied by 100. Mass by volume percentage of a solution is equal to mass of solute upon volume of solution multiplied by 100. A solution contains 40 grams of common salt in 320 grams of water. Calculate the concentration in terms of mass by mass percentage of the solution. Solution. Mass of solute, that is salt, is equal to 40 grams. Mass of solvent, that is water, is equal to 320 grams. We know mass of solution is equal to mass of solute plus mass of solvent. That is 40 grams plus 320 grams is equal to 360 grams. Mass percentage of solution is equal to mass of solute upon mass of solution multiplied by 100. That is equal to 40 upon 360 multiplied by 100 is equal to 11.1%. Summary. A solution is a homogeneous mixture of two or more substances. The major component of a solution is called the solvent and the minor the solute. The concentration of a solution is the amount of solute present per unit volume or per unit mass of the solution or solvent. Materials that are insoluble in a solvent and have particles that are visible to naked eyes form a suspension. A suspension is a heterogeneous mixture. Colloids are heterogeneous mixtures in which the particle size is too small to be seen with the naked eyes, but is big enough to scatter light. Colloids are useful in industry and daily life. The particles are called the dispersed phase, and the medium in which they are distributed is called the dispersion medium. That is all in this topic. Let us learn about separating the components of a mixture in our next topic.